climate change will make Earth a living hell. Humanity has long been enthralled by the moon, our cosmic friend in the vastness of space. However, what if we told you that there is currently an odd and mysterious event taking place on the moon, something that is beyond our comprehension of the universe? The world has a right to know what's going on with the moon since something strange is happening there right now. We have been investigating, studying, and admiring the lunar surface for many years. However, there is a secret that has stayed hidden from the public's view behind its tranquil facade. Strange abnormalities, enigmatic shadows, and lights that defy explanation have been observed by astronomers and satellite imagery recently on the lunar surface. Is it possible that what we're seeing has a logical explanation? On April 8th, a portion of Mexico, the eastern U.S., and eastern Canada were covered by a total solar eclipse. In preparation for the end of the world, some people cashed out their money. Fights broke out over water, as some others drove across the nation. A few of us simply experienced really bad luck that had nothing to do with the eclipse. As astronomical events go, eclipses don't happen very often. Total solar eclipses occur around once every 5 years, and there are usually 2 or 5 eclipses every year due to a number of factors. These eclipses rarely occur in the same location. Consequently, you will need to spend a lot of trip miles in order to see them on a regular basis. Because of Earth's rotation and the moon's elliptical orbit, these eclipses appear to shift in location. The moon does not orbit the Earth in a perfect circle. Seasons occur because more sunlight enters the northern or southern hemisphere depending on how the Earth wobbles in its orbit around the sun. As a result of these interrelated processes, eclipse patterns might appear to be somewhat unpredictable. However, contrary to common opinion, eclipses are actually simply a large rock moving across the sky that blocks our main light source. Every time someone with a big hat goes to a crowded movie theater, they create the same effect for the folks sitting behind them. A lot of things make our moon strange. One peculiarity is the moon's constant motion away from Earth. When you gaze up at the moon at night, it's hard to tell that it's slipping away from Earth. However, our knowledge tells us differently. Reflective panels were placed on the moon during NASA's Apollo missions in 1969. From them, we can deduce that the moon's current yearly distance from Earth is about 1.5 inches. A collision between the Earth and the moon occurred around 1.5 billion years ago, as determined by projecting the moon's present rate of recession into the past. The moon's formation occurred around 4.5 billion years ago. Therefore, we can't use the present recession rate as a benchmark for its historical performance. In an effort to learn more about the far past of our solar system, a team of researchers from the universities of UTCT and Geneva has been employing a variety of methods. We have just found the ideal spot to learn about the moon's long-term history of waning light. This information is derived not from lunar studies, but from signals detected in Earth's oldest rock formations in the beautiful Keene National Park in Western Australia. Some gorges cut through 2.5 billion-year-old rhythmically layered sediments. This type of sediment is known as a banded iron formation, and it is composed of layers of silic minerals and iron that were formerly abundant on the ocean floor and are now present on the oldest portions of the Earth's rust. At regular intervals, darker, thinner horizons alternate with layers of reddish-brown iron formation that are just under a meter thick, as shown at Joffrey Falls cliff exposures. In the darker intervals, you can see a more irritant, softer rock kind. An additional, consistent, smaller-scale variation becomes apparent upon closer inspection of the outcrops. The gorgeous seasonal river water has polished the rocks, revealing a pattern of alternating white, reddish, and bluish-gray layers on their surfaces. In 1972, Australian geologist A.F. Trennell raised the question about the origin of the different scales of cyclical recurrent patterns visible in these ancient rock layers. He suggested that the patterns might be related to past variations in climate induced by the so-called Milankovitch cycles. The Milankovitch cycles illustrate the long-term effects of minute periodic shifts in Earth's axial tilt and orbital shape on the amount of sunlight reaching the planet. At present, the principal Milankovitch cycles rotate every 400,000, 100,000, 41,000, and 21,000 years respectively. Over very long timescales, these changes have a significant impact on our climate. Past instances of extremely cold or warm periods, as well as wetter or drier regional climate conditions, are prime illustrations of the impact of Milankovitch climate forcing. The extent of lakes is just one example of how these climatic shifts have changed the planet's surface characteristics. They account for the cyclical verdant patches in the Sahara and the periodic depletion of oxygen in the deep sea. Even our own species has been impacted by the migration and evolution of flora and animals by Milankovitch cycles. The cyclical changes in sedimentary rocks allow us to read the signs of these changes. The climatic precession cycle is one of the Milankovitch cycles, and its frequency is proportional to the Earth-Moon distance. The precessional motion, also known as wobble or shifting orientation of the Earth's spin axis throughout time, is the source of this cycle. Approximately 21,000 years is the current span of this cycle. However, it would have been shorter in the past due to the Moon's closer proximity to Earth. This implies that we can approximate the Earth-Moon distance at the time of sediment deposition by locating Milankovitch cycles in older layers, then identifying a signal of the Earth's wobble and determining its period. Previous research showed that Milankovitch cycles may be preserved in an ancient banded iron formation in South Africa, thus supporting trends theory. As with the rocks of South Africa, the banded iron formations of Australia were likely deposited in the same ocean around 2.5 billion years ago. The cyclic fluctuations in the rocks of Australia, on the other hand, are more clearly visible, so we can examine them with far more precision. The banded iron formation in Australia was found to have rocks with numerous scales of cyclical variations that roughly recur at 4 and 34-inch intervals. According to analysis, we discovered that these cyclical fluctuations occurred around every 11,000 and 100,000 years. When we combine these thicknesses with the rate of sediment deposition, hence the investigation led researchers to believe that the 11,000-year cycle found in the rocks is probably associated with the climatic precession cycle, which has a substantially shorter duration than the present 21,000 years. After that, they determined the Moon-Earth distance from 2.46 billion years ago using this precession signal. By that point, the Moon had moved closer to Earth by nearly 37,300 miles, roughly 1.5 times the Earth's radius. In comparison to the present 24-hour day, this would significantly shorten the duration of a day to about 17 hours. Research in astronomy has provided models for the formation of our solar system and observations of current conditions. Since the Moon's creation 4.5 billion years ago, likely as a result of a collision between Earth and planet Theia, the two celestial bodies have been circling each other. However, these two bodies' orbits have evolved over the years. As the Moon continues its waning proximity to Earth, the final complete solar eclipse will be visible from Earth in the far future. When our species will be looking up at the sky, even though it might not be obvious from Earth, the Moon's speed varies over time, as is the case with all orbits. The speed of the Moon increases as it approaches the parag, the point at which it is closest to Earth. In the field of orbital physics, these details are crucial. Pointing in the direction you're headed and initiating a burn called a prograde burn can extend your craft's orbit and broaden your reach. Your orbit will lengthen, and your furthest point, your apses, will appear considerably farther than it did before due to the exponential effect of this speed increase. When dealing with other physical bodies, this is incredibly handy and could possibly unlock the ability to sling your ship even farther away. Consistent with previous NASA practice, this is how Voyager was able to escape the solar system by ejecting far larger celestial bodies and achieving an unrealistically high speed without using an excessive amount of fuel. We know what you're thinking. This physics lecture isn't weird, it's just the Moon. Well, what if we told you the Moon smelled funny? Aromas abound in our daily lives, whether it's the aroma of fresh-baked croissants with our morning coffee, the blossoming of spring outside our window, or even just a coworker's nice perfume. If you have felt any of the above mentioned today, then consider yourself lucky because astronauts on the ISS have to smell a real stink at this time. Have you ever wondered what the Moon smells like? The smell is dependent on airborne particulate matter, which is remarkably absent on the Moon. On the other hand, returning from the Moon, astronauts noticed that their gear had an unusual smell, reportedly of discarded gunpowder or pyrotechnics. Mel Moif, a French aroma sculptor and scientific consultant, claimed in an article for Nature that he had recreated the Moon scent using accounts from the first humans to set foot on the Moon 50 years ago. The Moon smells like spent gunpowder. This is exactly the smell Buzz Aldrin felt when he took off his helmet in the lunar module on the Moon in 1969 right after he left its surface, Moif wrote in Magnificent Desolation, The Long Journey Home from the Moon, 2009. Aldrin discussed the unusual aroma of the moon as soon as the second lunar astronaut, Neil Armstrong, got back to their lander. They were enveloped with a metallic odor that resembled gunpowder or the fumes released into the air by a firecracker explosion. In a 2015 interview with Space, Aldrin elaborated on his earlier description of the moon scent. It had the aroma of burning coal or ashes in a fireplace, especially when you sprinkled some water on it, he said. Aldrin was not the only Apollo astronaut who commented on the smell of lunar regolith similar to gunpowder in the lunar module. We instantly felt the smell of spent gunpowder with a metallic taste. It is this gunpowder aroma that is stuck in our memory more than other similar smells, recalled Apollo 17 astronaut Harrison Schmitt. Nevertheless, lunar materials that have since been analyzed on Earth did not exhibit this odor, although the exact reason has yet to be determined. Scientists suspect that it may be the result of a transient chemical reaction between oxygen and lunar surface particles, which eventually evaporates. We have learned a great deal about the moon over the years, but how many of us have ever considered what might happen if it were to wander away from Earth? To a large extent, the answer to this question can be found by considering the effects of lunar gravity on Earth. According to the Royal Museums Greenwich, this influence is mostly focused on the oceans. Curiously, the moon's gravitational pull on Earth's crust might become apparent if it were closer. Not only would Earth's rotation be slowed down and tides 8 times higher at half the distance, but seismic activity and volcanic eruptions would also be more common. Extinction and climatic chaos would also result. At a greater distance, if the moon were farther away, the tides would be smaller, which would have an impact on marine life and ecosystems around coastlines. Numerous marine and terrestrial creatures depend on coastal ecosystems and habitats for their survival. Their extinction would have a devastating effect on these animals. The moon plays a crucial role in the migration and navigation of numerous creatures, especially birds. Some people plan their reproductive cycles around the phases of the moon. Tide patterns and the special characteristics of moonlight also give rise to a plethora of interesting adaptations. Perhaps you're familiar with the concept of circadian rhythms. The day-night cycle is a result of Earth's orbit around the sun. Changes in the clocks or jet lag can easily disrupt the human circadian cycle. Then there are circulunar rhythms, which are associated with the phases of the moon. The impacts of circumlunar rhythms on many creatures are hard to pin down. Circadian and lunar clocks work together to influence the behavior of some animals. Always on the move, sandhoppers, Talatris saltator, work very hard to keep themselves in their ideal waterfront real estate. A small misjudgment would see them dried out on the beach, eaten by predators, or swept out to sea. To keep them commuting in the right direction, sandhoppers carry 2 compasses to help them with orientation and navigation on the beach. They have a sun compass in their brain and a moon compass in their antenna, so they know to stay buried during the day and can forage efficiently during the night. At low tide, the Great Barrier Reef also experiences its huge spawning of corals. When the moon is in the sky, it's a sight to behold. When coral polyps spawn, they deposit their egg and sperm into the water. Spawning occurs every year between October and December, just after a full moon, and is influenced by a number of variables like temperature, salinity, and food availability. The visual effect of this coordinated lunar timing is so dramatic that it can be seen from space. More temperature extremes and disruptions to the global climate may be on the horizon as a result of changes in ocean currents, which both drive and stabilize the weather. Different seasons occur in the northern hemisphere and the southern hemisphere due to the Earth's tilt, which is stabilized by the moon's gravitational influence. A world with less stability might see an end to seasons altogether or an increase in extreme weather events. With less influence on Earth's rotation and longer days and nights, a greater distance would be ideal because the moon would appear smaller in the sky. Less moonlight would also be seen. Nighttime predators wouldn't have an easier time finding food, and with a smaller moon in the sky, we'd lose an astronomical highlight. In 600 million years, the moon will be too far away to completely block the sun in a total eclipse. Is it possible that Earth will lose the moon before the sun explodes into a red giant, destroying the moon and humanity? The gravitational pull of both the Earth and the Moon is causing them to recede from one another. Our natural satellite is somewhat shaped like a football because of the tidal forces caused by Earth's gravity. The Moon is pulled toward Earth by the gravitational force of the tidal bulge. As a result of the lunar tides, the seas move, which causes friction on Earth's surface and slows the planet's rotation. When the Moon formed around 4.5 billion years ago, Earth's rotation rate was much faster, and the duration of the day was around 5 hours. The combined effect of these forces is to pull the Moon further from our planet because of their shared gravitational field. The Earth and the Moon must maintain a constant total angular momentum. A spinning object's energy is defined by its angular momentum. Your angular momentum increases as your spin speed increases. Less happens when you rotate more slowly. Another important factor is your distance from the system's center. Going further increases the system's angular momentum. Moving closer reduces your angular momentum. For the Earth-Moon system to maintain angular momentum conservation while the Earth's rotation slows, an external force must enhance the system's angular momentum. An orbiting object like the Moon getting further away increases angular momentum. A crash between the young Earth and an object around the size of Mars is the most probable source of the Moon's composition. Since the Moon's rotational speed is being slowed by tidal forces, it is tidally locking with Earth, meaning it always shows the same side as our planet. The rate at which the Earth rotates is likewise decreasing due to these forces. In roughly 50 billion years, the Earth will be in tidal lock with the Moon due to its sluggish rotation, causing it to permanently display only one side to the Moon. The Moon and Earth would then cease to recede from one another. Nonetheless, the Earth-Moon system will most likely be disrupted and destroyed when the Sun swells to become a red giant star around 5 billion years from now as it starts to die. If the Moon continues to recede from Earth at its present rate, it will have traveled an additional 117,000 miles by the time it is swallowed by the red giant Sun in approximately 5 billion years. Ultimately, neither Earth nor the Moon will be able to separate from the other. That is, the Sun will destroy them both. Although it is far away, it is yet another incentive to enjoy the Moon's presence in the night sky while it is visible.